Hello everyone, welcome to the platform of Unacademy, India's largest online learning platform, where you are preparing for your aspired examinations, that is the GATE and the PSC. Once again, I welcome you all to this platform. And if you are new to this platform, then definitely you don't know about the courses which I have started. So basically, I have started a course manufacturing. You can always go and check out the courses in the platform of an academy in this only channel. Let's crack Gate and ESE about the previous courses that I have already taught. Before moving it, let me give you a brief introduction about myself. My name is Vidyapati Kumar and I have a 4+ year of teaching as well as research and development experience. I have done ME from Jadavpur University and my specialization was production engineer. I have worked at CSIR, Central Institute of Mining and Fuel Research. I have qualified GATE twice, and I'm the author and co-author of various research paper publication of national and international journal of review. So basically, if you can follow me here at the unacademy.com at the rate of v.kesar. So when you are following me at the rate of v.kesar, you will be notified about the videos that I will be posting as well as the courses that I will be organizing for your benefits. And the most important thing for the today's session, I have told you that I have published a lot of research papers, and my research area was NTM, that is non-traditional machining process. I have done a lot of research in this area, in the non-traditional machining area, and this is what is going to be the today's session of. We are going to see the today's session. In this today's session, we are going to see the non-traditional machining process. So the question arises, what is the traditional processes? Then only we can go over the non-traditional machining processes. So definitely we are going to see these things in great details. But before that, if you have not downloaded the Unacademy Learning app, search this Unacademy Learning app in the Play Store and then download this app. After that, the you will sign in there with your basic credentials and then you will be getting a free special class. Basically you will be able to explore that section. So there is a free special class in which currently I am teaching the strength of material. So definitely you can watch the videos that I have already been uploaded. I have already taught you about the strength of material which is totally focused for GATE 2021. And there is another section that is for the paid section, that is for the plus subscription. Okay, so after getting subscribing to the plus subscription or the iconic subscription, you will be able to watch those full videos in the Unacademy Learning app. So definitely these things are free. These things are free. Like the YouTube, whatever you are seeing in the YouTube, that is totally free. So what are the benefits? The benefits are that daily life classes are there. So courses are structured in manner that is very much chronological in order. They are arranged, as well as test and quizzes you can give, and the unlimited access of the material are there. That is the unlimited access of that whatever the materials which are free in that Unacademy Learning app. You can go and check out those things. As well as for the plus subscription, if you have not purchased the plus subscription, do it now because it is totally worth it. It is 100% worth it, as entire syllabus is going to be covered there. So entire syllabus is covered, and definitely since you do not have the any time for to complete the GATE preparation, so definitely you can enroll for the 2 months plan, for the 3 months plan, so that your entire syllabus is going to be covered there. Daily life classes are there, so benefits are there. Definitely you can interact with the educator, you can ask the doubt with your educator, and whenever you are feeling that I'm not able to understand, definitely you can uh, ask the doubt and the educator will reciprocate with your doubts and try to clear your each and every issues. Courses are structured in manner that is totally planned in a such a way that is the courses are in a planned in such a effective way that after watching the lectures, of a particular course, you will be very much comfortable in that area. Now, tests and quizzes you can give, and the unlimited access of the whole content materials that is actually available in the Unacademy Learning app. This is what is the difference. Now, there is another subscription that is known as Iconic subscription. So basically, in this Iconic subscription, you are actually subscribing for a one level higher than the Plus subscription. So basically, the benefits that you are getting here is the benefit that is the Plus benefit. Each and every benefit of the Plus you are going to get it, and the next thing that you are going to get it is the personalized coach. So definitely you can choose any of your educator to be your personal coach, and that educator is liable to help you throughout your preparation of GATE and ESE. Definitely next is what study tracker would be there, so that educator will track your study. That educator will find where exactly is your weakness. Suppose you have given the mock test or the practice test and you are continuously getting a very bad marks, continuously scoring a very less mark. So what should be done here in this case? Even if you have covered, suppose the 70 to 80% of the syllabus has been covered by you, and even if then only also you are getting only a very bad marks or very less marks. Now, what should be the proper means like that? If you are getting these marks, so definitely there is some drawbacks. There is some fault that you are actually committing the mistakes. So here comes the personalized coach. Here comes their duty. What will do, they will find the personalized test analysis for you and let you know that, dear sir, you are having these kind of problems. Suppose that you are committing the mistakes in the conceptual part, then conceptual error are there. Suppose you are working in the silly mistakes are there. Suppose you are giving the like आप गलतियां कर रहे हैं silly mistakes में, तो ये गलतियां पहचानना बहुत ही ज़्यादा इम्पोर्टेंट है। गलतियों को ट्रैक करना बहुत इम्पोर्टेंट है। गलतियां अगर हमें पता चल जाएगा ये गलती है, तो डेफिनेटली आप वो गलतियां को नहीं दोहराएंगे, एंड दैट इज द मोस्ट इंपॉर्टेंट थिंग, दैट इज द पर्सनलाइज्ड टेस्ट एनालिसिस वुड बी done by the personal coach. Study planner would be there, preparatory study materials would be given, that is the PDFs and the other related things would be definitely given to you. These are the benefits, that is the plus benefit and the extra thing that you are going to get in this Iconic subscription. So these are the top educators of the Unacademy. So definitely subscribing into any of the courses, you are actually subscribing to the all all the courses for each and every educator. ठीक है, एक ही कोर्स में आप सभी को सब्सक्राइब कर ले रहे हैं. There are a lot of batches are also there for the year long, and definitely for these batches are for mechanical, civil, electrical, electronics, production, industrial, for each and every branches, and these are dedicated for the GATE and ESE. So definitely you can go and check out these things in their website. So suppose that the batches that has already been started, that are rank booster batches, suppose for the ESE prelims for the 2021, suppose the for the ESE prelims for the mechanical. So you can see here for the electrical, for the ECE, for the civil, for the mechanical, batch B is there, batch A is there, gate preparation in the 90 days are there, for the EC prelims preparations are the rapid revision batches are there. Okay, so rapid revision batches are also for the mechanical. So for the each and every branches, there are a lot of batches which has already been started in the month of October and the November. So definitely you can go and check out those batches. Suppose the new batches are also there, like doubt clearing sessions batches are there, rank improvement batches are also there. So definitely you can go and check out those batches. And whenever you are going to subscribe with my code SIRVK to get a maximum benefit in that courses. Suppose if you are planning for the plus subscription, so these are the amounts for the plus subscription. For the 1 month it is 5,500, for 6 month it is 24,750, for 18 month it is 38,500, for 24 months it is 44,000 something. So definitely for you guys, definitely who are giving the GATE 2021, you can enroll in these of the courses. And for those who are in second year and third year, definitely you can go and check out these things, that is for the 18 months plan and for the 24 months plan. And in each of the plans, whenever you are going to subscribe with my code SIRVK, SIRVK, to get a 10% off, as well as you will be automatically enrolling in my personal guidance program. Suppose for a 12 months plan, if you are enrolling, so suppose the price is what, 30,250, but if you are using my code SIRVK, then it will be discounted amount you will be getting as a 27,225. So this is for a plus subscription. This is for a plus subscription. Next is for the iconic subscription. So for the iconic subscription, these are the prices, and definitely you are going to, if you are going to subscribe this iconic subscription, so use my code SIRVK, SIRVK, to get a 10% off in each of the plans. Now see here, my dear friend. So today we are going to see the non-traditional machining process. But before that, let me tell you something. So basically, we have seen, I have already covered the machining metal cutting part. So those who have not watched my metal cutting part, definitely they can go, they can check the description of this video, and from that they will find the playlist. And from that playlist, 12 videos are there for the metal cutting part. You can go and check out those videos and complete your metal cutting part. Now, after that thing, uh, we have seen that basically the machining, just a minute. So basically the machining, that we have seen, that they are of two types. What are the two types? Basically, they are of conventional conventional machining, and second is known as non-conventional. Non-conventional. Now see here, this conventional means what? So conventional is also known as traditional machining. Traditional machining. And this non-conventional machining is also known as non-traditional machining. Non-traditional machining. Now, what is the meaning of traditional and non-traditional? Now, see here, अगर आप basics समझें, if you would look to the basics, what is the thing that you have studied till now? So you have studied till now that the processes such as the metal cutting processes, you have studied metal cutting processes, right? Metal cutting processes. So what are the metal cutting processes you have studied till now? So you have seen that there is a lathe operations you perform. Suppose the turning, a lot of processes are there. You perform in the lathe. Now you also perform the machining in the milling, isn't it? You have already seen that in your BTech workshop, you have also done some metal cutting processes in the drilling machine. Okay. Similarly, you have also done the metal cutting in the grinding. Now here comes the thing. So basically in general मतलब क्या, इन ट्रेडिशनल वे मतलब पुराने समय से हम जनरली कौन से प्रोसेसेस को यूज करते आ रहे हैं? We have already been using these kind of processes. So generally these processes are used, and hence these are known as traditional machining, है ना? Traditional machining जो चला आ रहा है, that those machining which has already been used till now. Now, here comes the another classification, that is the non-traditional machining. That is the non-traditional machining. So, वैसे machining processes जो पहले नहीं थे, अभी आ गए हैं, मतलब इस डिकेड्स में आ गए हैं, 10 साल, 15 साल, 20 साल में, इस डिकेड्स में वो आ चुके हैं. So those things that are those machining processes are known as non-traditional machining processes. Now, the problem is that we have to understand why we exactly need the non-traditional machining process. If we are very much happy, suppose that if I want to make this part of thing, or suppose if I want to make these things, anything that we want to make, If we are happy, if we can make it with these conventional machining processes, then why there is a need of the non-traditional machining processes? So try to understand, my dear friend, there are some of the points that you should always remember, that you should always think before asking these questions. See here, point is that the tool and workpiece are in physical contact, are in physical contact. Now see here what is happening. When the tool and the workpiece are in the physical contact, so basically the problem that is happening is, suppose these kind of marks are there. And if you would watch these things in your like microscopic level of that machined part, if you are watching these things on the machined surface, you will be finding these kind of peaks and the valleys as a surface finish. So basically the problem is that since there is a physical contact, so surface finish is what? Poor. So poor surface finishes. Now see here, no, you cannot say the very poor. So basically surface finish are not very good, right? So basically the surface finish are not very good, and you require a lot of great quality of surface finish. For that processes, for that purposes, you have to switch for the PM process. Next thing that you should always, you would appreciate, suppose that if I want to machine the cast iron, fine, if you want to machine the cast iron block, then if this is the tool material, if this is the tool material, and you are machining the cast iron block, then what is happening? Tool should be, must be higher than the block, isn't it? Suppose this is the tool, the suppose this is the block, fine, and now what you are doing it, this is the tool, fine, this is the tool, and with this tool you want to machine it. So definitely the hardness of the tool, the hardness of the tool and the hardness of the workpiece, right? So definitely you would appreciate this point, that tool must be harder than workpiece. Now I would ask a question with you, just think about it, that if, what if I will have a workpiece which is very much hard, means like that is very much harder, then how we can machine it? अगर हमारा वर्कपीस ही बहुत ज्यादा हार्ड है, तो फिर हम मशीन कैसे करेंगे उसको? या फिर हम उससे ज्यादा तो हम फिर तो डायमंड आ जाएगा, फिर डायमंड से मशीनिंग करेंगे. Think about it. So sometimes the problem is that we can achieve a lot of configuration, a lot of shapes from the conventional machining, but the problem is that हमें कॉस्ट ज़्यादा लग जाएगा, प्रॉब्लम आएंगी, और कुछ हद तक हम कर भी नहीं सकते. For these things, definitely we are switching for the non-traditional machining processes. Okay, now see here. So the problem that we have seen, that these processes, that is the conventional machining processes, are not able to machine very hard material. Okay, now if we want to make a very complicated shapes, suppose that this is a block, fine, this is a block, and in this block we want to make some complicated cavity like this. Suppose these kind of cavity you want to make it, this is the cavity. Okay, now this is very much impossible to form these with the non-traditional, with this the metal cutting process. So we are using the non-traditional machining processes to machine these. So definitely I hope that you understood the basic idea why exactly we need the conventional machining process, and what are the limitations of that conventional machining processes. And here comes the non-conventional machining processes, which we are going to study in this throughout the lecture. for the further analysis. So see, I am not saying that you cannot make it with the conventional machining process, but definitely you can make it the complex shapes. But the problem is that you have to give a very high effort, and a sophisticated machines are also needed for that. So here comes the non-conventional machining processes. So suppose that the new materials having a high strength, hardness, such as pneumonic alloys, or the alloys with the alloying elements. Suppose the alloying elements are the tungsten, which is super alloy, right? So for these conditions, they are very tough. We have seen in the welding, for the tungsten inert welding processes, we have seen that we use is the tungsten tool, है ना? TIG, tungsten inert gas welding. Why we use the TIG? Because that tungsten part is non-consumable, तो उसका कंज्यूम होगा ही नहीं, या बहुत ही कम कंज्यूम होगा. क्यों कम कंज्यूम हो रहा है? क्योंकि सर वो तो बहुत हार्ड है. अब उसमें अगर आपको मशीनिंग करना है, सो इट इज नॉट कप ऑफ टी फॉर द कन्वेंशनल मशीनिंग प्रोसेसेस. फॉर एग्जांपल, इफ वी सी द molybdenum or the columbium, these are very difficult to machines by the traditional methods, and here comes the non-traditional machining process. So basically, for the non-traditional, for these kind of materials are used for the aerospace applications. Fine. For these applications, we use it, and hence we make it with the very precisions. So by conventional machining, the MRR reduces with the increase in the work material hardness. These are the points. Now, need for the development of non-traditional machining processes which utilizes the other such as electrochemical processes. We will be seeing these things. I have told you about the complex ships, right? So basically, we want to make the very complicated ships, and we are going for the non-conventional machining process. Most important thing, very high accuracy. Suppose if I want to make something of very high accuracy, very precision things, definitely we will go for the non-traditional machining processes. Why? See, अरे सर इसमें तो surface roughness ही मतलब इतना ज्यादा है ना. Here surface finish is very bad. So how we can talk about the very much precision and accuracy? No, nothing. So for that reason, we are going for the non-conventional. So I hope you got a very good idea. Now see here, what are the salient points that you should remember for the non-conventional machining processes? That is, they are classified. So different forms of energies are there uh, involved while the machining is performed. Basically, the non-conventional machining processes. Okay. So see here, different forms of energy directly applied to the workpiece to have the shape transformation or the material removal from the workpiece. So basically, you can think about that. Suppose there is a workpiece. Suppose this is your workpiece. And with the help of some energies, right? Just think about it, that with the help of some kind of energies. Don't think about that abhi zyada complicated na kare. Please try to think in a very streamline, that there are some kind of energies which are actually involved to machine this. Suppose this part has been machined on the workpiece. So that is what is being told, that energies are involved. Next is that there is no chip, no lay pattern on the workpiece, and no direct physical contact between the tool and the workpiece. What exactly it means? What exactly it means? It means that suppose this is my workpiece, right? This is my workpiece. Now this is my tool. Suppose this is the tool. Suppose this is a tool, right? Suppose this is a tool. Now see here, you will not understand that why you sir has made these things. Don't worry, don't worry. Just think about it, that this is a tool and this is a workpiece. And what happens? You want to machine the workpiece, and they are not in a physical contact. They are kept with some kind of distance. This is the most important thing that you would see in the unconventional machining processes. See here, the next part is that tool material does not have to be harder than the work material, है ना? तो क्या होता है ना? Generally, if you would see, and I will be teaching you the EDM processes, electrical discharge machining processes are there for the unconventional machining processes. So we generally machine lot of very hard materials with the copper tool, with the copper tool, with the copper tool. and comparatively very means like they are not very hard with the comparison with the workpiece. So that is what I am going to tell you, that tool material necessarily does not should be harder, है ना. वर्क पीस से टूल मेटल सॉफ्ट हो सकता है, कोई दिक्कत नहीं है इसका. Next thing is what economic metal removal rate does not decreases as the work metal gets harder. Fine. So these things are there. Now understand that classification of the non-traditional machining process. So basically, how we are going to classify? I have told you that the non-traditional machining processes are basically classified on the basis of energy, है ना. किस एनर्जी से आप मशीनिंग कर रहे हैं उसके बेसिस में क्लासिफिकेशन होती है. व्हाट इज दैट? You see here, so there is a non-traditional machining processes. So this is the non-traditional machining processes. So suppose if in the machining thermal energy is involved, okay, thermal energy is involved, then that is known as thermal energy non-traditional machining process. Suppose if you are involving, suppose in that electrochemical energies are involved. So what is the electrochemical energies? So basically it's like आपका chemical reactions होता है, basically in that chemical reactions would be taking place, and based upon that chemical reactions you are performing the machining operations. Next is what chemical energy method. Now see what is in this chemical energy method. So basically what is happening, suppose these energies are produced due to corrosive agents, right? Agar you would take some corrosive agent, and definitely by those corrosive agent you are actually going for the machining, then that are known as the chemical energy method. So don't worry, we are going to see even these things in a subsequent slides also. What is the mechanical? So next is the mechanical energy method. So basically in this mechanical energy methods, what exactly we are seeing, we use some kind of abrasives, we use some kind of fluid, okay, and see here, by the use of the fluid, by the use of the abrasive, we strike on the workpiece, and by those things what is happening, mechanical energy is involved during the machining. Okay, so basically just this is a brief idea about the energy classification and how we are going to classify the non-traditional machining processes. Now let's see here these things. So you have seen, I have told you that there is a thermal energy involved. Now these are the thermal energy methods, these are the thermal energy methods, and what are the processes? Understand, that is the electrical discharge machining, that is the EDM, is EDM. Next machining process is known as laser beam machining processes. Fine. So next process is known as plasma arc machining process. Next process is known as electron beam machining process, and next is ion beam machining process. So basically in these processes thermal energy is involved, है ना. थर्मल एनर्जी इन्वॉल्व होता है. अभी आप बोलिएगा कि थर्मल एनर्जी इन्वॉल्व होने का मतलब क्या हो रहा है. Let's see here. If you could see in this slide, you would be understanding that basically in the EDM process you are actually producing a electric spark. Okay, so just think about it, what is happening. So there is a tool, there is a workpiece. So in this, between this tool and the workpiece, a electric spark is produced. And due to this electric spark, what is happening, the fusion and the melting happens. So suppose that this is the workpiece. In this workpiece, fusion of the materials or the melting of the metals takes place, and after that they are vaporization. So see, if you're not understanding, that's completely fine, what I want to tell you, that this is a very introductory lecture, and just focus on whatever I'm going to tell you. So basically in the electrical discharge machining process, so with the help of the electric spark, you are actually producing the machined part. Fine, a workpiece is machined. And what is the mechanism involved in that? The mechanism is involved in that is the fusion or the melting followed by the vaporization. Now see, for the laser beam machining, suppose for the laser beam machining, here the laser beam machining, in the laser beam machining what is happening, mechanism is going to be same for each and every processes which are involved in this thermal energy method, but the source is changing. Source means what? Mechanism in this मतलब क्या? अभी देखिए, source is what? Here the source is powerful radiation. So suppose that due to the radiation you are giving the powerful radiation on the workpiece, and due to this powerful radiation what is happening? Again fusion or the melting happens of the workpiece material, and then followed by the vaporization. So mechanism is going to be same for these processes, but the sources are going to be changed, है ना? मतलब एंड रिजल्ट हमारा क्या है? एंड सपोज करें कि आपका कोई एक काम हो रहा है, आपका कोई काम करना है, तो आपका वो काम हो नहीं रहा है, तो आप वो काम करवाएंगे किसी से। अभी देखिए, वो काम आप किसी से भी करवाएं, सोर्स में भी डिफरेंट है ना, वो काम आप किसी से भी करवाएं, लेकिन वो एंड रिजल्ट में क्या, एंड तो आपका काम होगा ना, तो वो काम आपका क्या है, दैट वर्क इज योर मैकेनिज्म दैट इज गोइंग टू बी सेम, बट सोर्स क्या, अब आप किसी और से करवाएं, आप किसी से भी करवा लें, अपने फ्रेंड से करवा लें, अपने अपने पिताजी से करवा लें, अपने किसी से भी करवा लें, तो डेफिनेटली सोर्सेज में बी गोइंग टू बी डिफरेंट, but mechanism is going to be. Now see here, next thing we can see from these things is the plasma. So in the plasma arc welding, in the plasma arc machining, sources is going to be high temperature plasma. Fine, high temperature plasma is the source. Next, for the similarly for the EBM, for the electron beam machining, high speed electron is the source. Suppose what is the meaning of high speed electron? So suppose this is the workpiece and the high speed electron is moving here, and they are just striking on the workpiece, and based upon that striking, the cavity is formed or the machining is done. So basically these things are involved. Suppose for the ion beam machining, high temperature ions are involved. So basically in the gate examination, how the questions are asked, they will be asking that suppose tell me that EDM process, in the EDM process what is the mechanism by which it is performed. So by the mechanism is what? Fusion or the melting followed by the vaporization. And how it is how the EDM process is performed? So basically it is by the source is what? Electric spark. Next thing, the question that is asked in the gate is that EDM is the which kind of energy processes, that is in which energy it is involved. So EDM जो है किस energy के साथ involved है, and that is what? That is the thermal energy. So based upon that the questions are asked. Let us move towards the next process, that is the chemical energy method. So basically I have told you that what is happening in the chemical energy method. So see here. So in these methods, what is happening? Etching. Etching is there. So basically, what is the etching? You would be understanding. I will be showing you the printed circuit board. What is happening? So basically, in this process, a controlled etching of the workpiece material in contact with the chemical solution. Suppose that this is a material. Suppose that this is a workpiece. Try to understand here. And suppose if I want to, means like form these kind of things. मुझे अगर कुछ इस तरह का शेप्स फॉर्म करना है, सो व्हाट आई विल बी डूइंग, जस्ट आई वांट टू मेक अ शेप. सो व्हाट आई विल बी डूइंग, आई विल बी परफॉर्मिंग अ कंट्रोल्ड इचिंग, है ना, छोटा सा इस तरह का पार्ट कर लूंगा. लेट मी शो यू द प्रिंटेड सर्किट बोर्ड्स. See here, suppose if I want to make these kind of things, so see here, है ना, इस तरह का, if I want to make these kind of shapes. So how we can make it? By the controlled etching. By controlled etching is a process. So है ना, एक process के through क्या करते हैं, उस part को controlled way में machine करते हैं और फिर हमें final product मिलता है. We are going to see these things in a great detail. Don't worry, these things are a printed circuit board we see in बचपन से लेके अभी तक हम कितने बार इसको देख चुके हैं, right? So we are going to machine these things with the non-traditional machine. So basically see here, in the chemical energy method we use the etching method for the machining purposes, right? अब वो etching करते किससे हैं? by the use of the chemical solutions. And these method, in this method the machining is done, and this is known as chemical machining method. Fine. Now what is the source, how we are means like machining? So basically the source is the corrosive agent. So any agent which is corrosive in nature, you use that agent, and by that using that agent the machining takes place. Now the process, the mechanism involved in that is known as corrosion, है ना? अब आप corrosive agent यूज करिएगा तो वो definitely corrosion करेगा ना. So basically the machining is based upon the corrosion mechanism in this chemical energy. Now see, let's see the next method. So in the next method, what we can understand from here is that this is the mechanical energy method. So I have told you that with the help of some fluids or the particles, we will be just impinging, right? हम सपोज करें कि एक छोटा सा पार्टिकल है. अगर आप सपोज करें कि आपके पास एक बड़ा सा गेंद है और आपका एक 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 नीचे में कोई एक सरफेस है, ठीक है, जो कि सपोज करें फोम का सरफेस है. अब आप एक बॉल लेकर के फोम के सरफेस पर अगर मारेंगे तो आपको पता चलेगा कि वो फोम का सरफेस पे क्या हो जाएगा, वो दब जाएगा, है ना? तो देयर वुड बी अ कैविटी दैट विल बी मेड बाय दैट ball. So that is the same thing, just think about it. So this is the workpiece, suppose this is a workpiece. Now what you are doing it with the help of some kind of abrasives, what you are doing, suppose you are just striking that abrasive on this workpiece. Suppose this is the workpiece, and this is what this is done, this is, suppose this is an abrasive particle. Now you can think about this abrasive particle such as a stone, right? अगर आप स्टोन लें और फेंक दें, दीवार पे मार दें, तो स्टोन क्या करेगा? स्टोन जो है, स्टोन के पास एक एनर्जी चला जाएगा और उस एनर्जी के कारण क्या होगा, वॉल पर एक निशान बन जाएगा, है ना? And that is the same thing that is happening by the help of the fluid or by the help of the particle. What is happening? You are actually impinging on the workpiece, and hence the cavity is actually forming. Cavity or the holes or any kind of machining is actually happening due to these kind of things. So what is happening? So here the source is fluid and the particle. And what is happening here? What is happening here? What is happening here? So basically here the shear is involved, right? Shear is involved, and due to the shearing action of the workpiece, of that part of the workpiece, the means like this is the mechanism that is involved, that is known as shear mechanism for the machining of the mechanical energy. So I hope these methods are what? Ultrasonic machining, USM, abrasive jet machining. In this abrasive we are using it, abrasive particles we are using it. In this ultrasonic we use the ultrasonic vibration, ultrasonic vibrations we use for the machining purposes, and the water jet machining. So basically in this water jet machining we are using the water, right? We are using the water. And there is another machining that is also known as AWJM. That is what? That is abrasive water jet machining. So basically in this, what we are using it, we are using the abrasive particle, we are using the water, both the things we are going to use it for the machining purposes, and that is comes in the umbrella of the mechanical methods. So I hope you are getting a very good idea about it. Now next method is known as electrochemical energy method. So basically in this electrochemical energy method, electrochemical energy is involved, and the examples are like what? ECM, electrochemical machining, electrochemical grinding, that is ECG, electrochemical honing, that is the ECH, and the electrochemical deburring, है ना? Deburring का मतलब क्या होता है? कभी कभी जब मशीनिंग करते हैं तो उसमें बर्फ फॉर्म कर जाता है. For that purposes what we are using, we are just deburring to get a very good surface finish like that, and we are performing the ECD, that is the electrochemical deburring. Now what are the sources that are involved in that, and what is the mechanism of this electrochemical energy method? So basically if you could see here, the methods are ECM, ECH, and the ECD. So basically in these things, what we can understand, sources is the electric current. So what is happening, with the help of the electric current we are actually machining these things. How we are going to machine these things, we are going to see each and every processes in a very great detail and try to analyze how these sources and mechanism are important for that. But why I am listing these sources and mechanism exclusively just in this introductory video? Because my dear friend, it is very much important for the gate and the ESE point of view. The questions are directly asked from that. How the questions they are going to ask? Suppose that, so first of all, just try to understand here, the source is what? Electric current. And how this is what? So suppose this is a workpiece, just understand this is a workpiece. So with the help of the electric current, suppose this is an electric current which is flowing like that. Now with the help of electric current, so this is an ions. Suppose this is the ion. So suppose this is the molecule particles of the workpiece. So what is happening? They are getting, they are getting like, so basically here the ion dissolution is there. ion dissolution होता है और इसके कारण क्या होता है, वर्क पीस का वो पार्ट निकल के चला जाता है, ठीक है। तो सपोज करें दिस काइंड ऑफ दिस कैविटी हैज ऑलरेडी बीन फॉर्म्ड. So by these things we are actually getting the machined part. How the questions are asked, what I have told you, that suppose there is an electrochemical energy method. Suppose in the question it has been asked that there is an ECM process. Tell me which energy is involved in the ECM process. So answer you will be what? Electrochemical energy. Now the question will be asked like that, that in the ECM, what is the source of machining? Source will be what? Electric current. Electric current. Now they will be asking that mechanism involved in the ECM process is what? That is the ionic dissolution. So these things are common for the ECH mechanism is ionic dissolution. Again the ECD mechanism is the ionic dissolution. Now see here, next thing, that is the electrochemical energy method. Now you have to understand this thing. Suppose, so this is a hybrid machining. ओके, व्हाट इज एन हाइब्रिड मशीनिंग? अभी तक हमने क्या पढ़ा? अभी तक हमने पढ़ा कि सर एक मशीनिंग प्रोसेसेस होते हैं जिसके थ्रू हम मशीनिंग कर रहे हैं. अभी देखिए इसमें मैकेनिज्म क्या होता है, सीयर इन्वॉल्व होता है, या तो फ्लूइड आप यूज कर रहे हैं या तो पार्टिकल यूज कर रहे हैं. तो उसी तरह से हाइब्रिड मशीनिंग में क्या होता है, आप क्या कर रहे हैं, यू आर यूजिंग द इलेक्ट्रोकेमिकल मशीनिंग थिंग्स, दैट इज यू आर यूजिंग द इलेक्ट्रोकेमिकल एनर्जी and you are using the mechanical energies also. By use of these kind of energy you are doing the machining, and that is the machining known as hybrid machining. So basically you can understand in the ECG, electrochemical grinding, what is happening. So you are using the electrochemicals, so you are using the chemicals for the machining, as well as in the grinding. In the grinding what is happening, the abrasive particles are there, ठीक है. ग्राइंडिंग व्हील अगर आप देखें तो कुछ इस तरह का एब्रेसिव पार्टिकल्स होता है, एंड दोज एब्रेसिव पार्टिकल्स आर एक्चुअली giving the mechanical energies, and by those things you are actually getting the it's like machined thing. The mechanism involved is the ionic dissolutions and the shear क्यों, मैकेनिकल होगा तो shear होगा और इलेक्ट्रोकेमिकल होगा तो ionic dissolution होगा, right? And what are the sources? So suppose that there is an electrochemical machining, so in that electric current will be the source, and in the mechanicals I have told that there is this is a grinding process. So suppose this is a grinding process, grinding will be involved for the mechanical energies. Now suppose there is a no grinding machines are there, so definitely for this generalized I can say that there is a tool, there will be a tool involved in that, and that is, in this case, it is a grinding wheel. Now suppose that let us try to implement the concepts whatever we have learned till now to the this gate problem. So there is a gate problem which has been asked in gate 2014. In this question was asked, very good question, the process utilizing mainly thermal energy for removing material is what? Now see here, we have seen that in case of a thermal energy, right? See here, so see here, so in case of a thermal energy, what are the concepts we have seen? That thermal energy is what? So EDM is there, LBM is there, PAM is there, EBM is there, and IBM is there. यही methods तो हैं जो thermal energy में use होते हैं. अभी देखिए, don't go into details of that सर ये methods क्या होते हैं. I'm going to means like to tell you each and everything. Don't worry about, but this is an introductory video. Okay, so see here, So these are the energy method, thermal energy method. Now from here you can see here the options that is given here is ultrasonic machining, electrochemical machining. So first of all, try to analyze these things. Ultrasonic machining, we have seen that there is ultrasonic machining in case of a mechanical energy. See here, in case of mechanical energy, we use the ultrasonic vibrations for the machining part. And what is the abrasive? So in the abrasive jet machining, we use the abrasive for the machining part, right? So what we can say here, sir, the process utilizing for these ultrasonic and this abrasive is what? Mechanical energy, isn't it? This is the mechanical energy is involved. Now in this abrasive jet machining, again the mechanical energy is involved. Now, in case of electrochemical machining, we have seen that electrochemical reactions are there, right? So for those things, electrochemical reactions is going to be happening, and for those reasons, my mechanism will be ionic dissolutions, and the electrochemical energy is going to be there. That is the electrochemical machining, ECH and ECD, है ना? इन सभी चीजें के लिए ये सब होता है. We are going to see. So this is what electrochemical energy is involved. And in this laser beam machining, what we have seen that there is a laser beam that is going to be struck. Laser beam will be striking on the workpiece, and by that striking on the workpiece, machining is going to be happening. So what is happening when the laser beam is striking on the workpiece? Temperature is raised. Temperature is raised on the workpiece. Try to visualize this here. Oh, this is a workpiece, and on this workpiece you are giving a laser beam. So when you are giving a laser beam, so what will happen here? So here temperature will rise. Temperature will rise. And when temperature will rise, then the machining will be happening. So here the thermal energy is involved during the machining. Hence the laser beam machining, thermal energy is. So the option D would be the correct answer. Fine. Let's see the some of the shape and the cutting capability. What are the shapes of the features, shape features we can make from the non-traditional machining processes, and for which kind of non-traditional machining process we are going to imply which kind of shapes. Suppose that suppose that there is a process which is known as laser beam machining. Laser beam machining and electron beam machining. Now, with the help of these two machines, we can make the micro machinings. We can do it with the help of that. We can do the micro machining as well as we can do the micro drilling. We can do the micro drilling. व्हाट इज द मीनिंग ऑफ माइक्रो, मतलब बहुत ही छोटे लेवल पे, मतलब कि सपोज करें कि मशीनिंग जो जो साइज है आपका, जो प्लेट की साइज होगी, जो आपका वर्क पीस का साइज होगा, वो बहुत ही छोटा होगा. दैट विल बी इन द माइक्रोम्स. ओके, सपोज दैट यू आर ड्रिलिंग द होल्स of a micron. Suppose that 10 micron is the diameter of the hole. So these are the dimensions would be in the micron. Fine. So that is the micro drilling or the micro machining. Clear? And this is known as LBM and EBM. Okay. Now next part is this. Next, suppose if you want to make a standard hole like that. Suppose if you want to make a standard hole. Okay. So how you can make it? So the process involved in this is known as electrical discharge machining process. Discharge machining processes. So this is known as EDM. Okay, and next process is another process known as ultrasonic machining. Ultrasonic machining. Just let me write like that so that you will not have any confusion. Ultrasonic machining. So that is known as USM, ultrasonic machining. So with the help of these machining, what you are making the standard hole and the cavity sinking. So basically the cavity sinking is made by this EDM process, and the standard holes are also made by these things, both the processes. So basically in the cavity sinking we are going for the EDM things. तो ये दोनों प्रोसेसेस से आप स्टैंडर्ड होल्स एंड कैविटी सिंकिंग बना सकते हैं. कैविटी सिंकिंग का मतलब क्या हो गया? सपोज करें कि if this is a workpiece, fine, and you want to suppose that you want to make these kind of part, this kind of cavity you want to make. How you can make this kind of cavity? So basically what you are going to do, you will make a tool. You will make a tool of this same dimension. You are going to make a tool of this same dimension, and with help of that machining processes, that is the EDM machining process, what you are doing, you are machining. तो क्या होगा ना, जितना इसका डायमेंशन होगा उतना ही का डायमेंशन जस्ट रेप्लिका यहाँ पे बन जाएगा. रेप्लिका यहाँ पर बन जाएगा, एंड दैट इज द थिंग दैट वी नोन एज कैविटी सिंकिंग, है ना, सिंक कर जाना. नेक्स्ट प्रोसेस इज नोन एज, so next, suppose if you want to, so suppose that next thing that I am telling here, there is a electrochemical machining process. Next process known as electrochemical machining, so that is known as ECM. Now, by the help of the ECM machining processes, we are actually producing the fine hole drilling and and contour machining. What is the contour machining? So basically, fine hole drilling, you can understand that there is a very fine hole you want to make it, है ना? That you can make it with the ECM. Now, what is the contour machining? So basically, see here. Suppose these kind of profile you want to make it. Suppose this is the profile that is of the workpiece. Fine. So this is the contour that you want to make it, and these kind of contour is made by the ECM process. Fine. Next process that you have to see here. So I hope these things are very much clear to you, and definitely you are understanding these things. And if you have any kind of doubt, you can always reach to me, okay, and I will try my level best to make you understand these things. Next is your plasma arc machining or plasma beam machining. Fine, both are the basically the same. So basically in the plasma beam machining, that is the PBM. So basically we are using these PBM, plasma beam machining process, for to make a very clean, neat and clean profiles. Is clean profiles you want to make it, or you want to make the very clean and rapid profiles. बहुत ही जल्दी से आप अगर किसी को कट लगाना चाहते हैं, बहुत फाइन कट होना चाहिए. सपोज यू वांट टू मेक सम रैपिड कट्स, और और प्रोफाइल्स यू वांट टू मेक इट which are very much clean, है ना, मतलब पूरा नीट एंड क्लीन, मतलब सरफेस फिनिश भी बहुत अच्छा होना चाहिए. उस तरह का चीज अगर आप करें, दैट रीजंस यू कैन गो फॉर द प्लाज्मा बीम मशीनिंग. next is next part is AJM, abrasive jet machining. Now see here, what is the abrasive jet machining? So basically, if we want to make some shallow pockets, what is a shallow pockets? See here, suppose that this is a workpiece. Okay, this is a workpiece. And on this workpiece, if you want to make a pocket like this, pocket मतलब क्या होता है? Suppose करें कि आपकी जेब की pocket है ना, तो जेब, तो वो छोटा सा कैसा pocket हो जाता है ना, जहाँ पे कुछ चीज आप रख सकते हैं. But the same thing you want to, if you want to make a pocket in the workpiece like that. So suppose this is a pocket. Suppose this is the pocket. Fine. Let me color it so that you can easily understand. Fine. This is a pocket that you can understand. This is a very pocket that has already been formed. This is known as pocket. Now when this pocket is of very less depth, right? So this depth is, you can see here, this depth is very much less, that is shallow in nature. So if you want to make that shallow pockets, you can make it with the help of the abrasive jet machining. So I hope you are understanding these things. Let us try to find some of the salient points that are involved in this abrasive, in this non-traditional machining processes part. See, you don't have to like worry about these parts कि आपको समझ में नहीं आ रहा है या फिर आप कैसे याद रखें. डोंट वरी अबाउट इट. मोर एंड मोर मीन्स लाइक जितनी बार आप उस चीजों को देखेंगे, जितनी बार आपका अंडरस्टैंडिंग बढ़ेगा, आपको सभी चीज याद हो जाएगा. ठीक है, तो बेसिकली दीज आर द फैक्ट्स दैट आई एम गोइंग टू टेल यू, एंड आई एम गोइंग टू एक्सप्लेन you in the next videos about the EDM process, of the ECM process, of the LBM, EBM, a lot of process, each and every process that I'm going to discuss it. Now, this is the salient point that I'm going to discuss it here. So EDM has a lowest specific power requirement. So the power requirement in case of EDM process is less, and hence it can achieve a sufficient accuracy. So these are the most important point. From these points only the direct gate questions are asked. You will be understanding these points more clearly when I will be teaching you about the EDM process. Next is what? For the ECM, it has having the highest MRR, means what? Material removal rate. So again I am telling, if you have not watched my metal cutting series, you can always go and watch the 12 videos of the metal cutting, that you will be getting the understanding of what is the MRR. So basically, what is the material, that is the material that is getting removed from the workpiece, that is the MRR, and the rate by which it is removed, that is known as material removal rate. So in case of a ECM process, material removal rate is high, and for the USM and the AJM, that is the ultrasonic machining and abrasive jet machining, MRR will be low. MRR will be low. So okay, so here, see here, so MRR will be low, and combined with the high tool wear rate. So basically what you need to understand, that in the EDM process, specific power requirement. So power requirement is what? Lowest, and accuracy is good. For the ECM, highest material removal rate is there. For the USM and for the AJM, MRR is what? Low, and हाई टूल वियर रेट. टूल वियर मतलब क्या? ये टूल वियर क्या होता है? ये टूल वियर क्या होता है? अभी आप सोचें, suppose that what is happening, suppose this is a tool, so what is happening? This is a workpiece. Now if there is a abrasive particle that is going to come here, so definitely that abrasive particle will form a cavity and the machining would be performed. Now due to this abrasive particle, may strike to this tool also. Fine. Or what is happening to do this case is, what is happening, tool. This is the tool. This is the tool. So basically the tool will have some kind of wear. So there will be a wear in that tool, and this tool wear is known as, this is going to be very high in case of USM and the AGM. Don't worry about if you cannot understand. Again, I'm telling you, I'm going to discuss these things in very great details. This is just an introductory lecture, and you just try to absorb as much as you can from this lecture. Next is the LBM and the EBM has a very high penetration rate and the low MRR. Fine. And I have told you where they are using. They are using for the micro drilling, sheet cutting, है ना, ये हमने आपको बता दिया. CHM, that is the chemical process. In the chemical machining processes, what is happening, they are using for the PCB, manufacturing of the PCB. I have told you, how the PCBs are performed. See here, these are the PCB, that is the printed circuit boards. Basically, just a minute. Printed circuit. So you can see that is commonly known as PC. So in this PCB, see these kind of profiles are there, right? So how you can make these kind of profile, how you can make these kind of profiles, or these kind of profiles. So you have seen, so basically with the help of the etching process, you are performing the machining. That is a very controlled machining is there, है ना. controlled machining के कारण क्या होगा, अगर मान लें this is your thickness of the plate. तो अगर आपको थोड़ा सा ही करना है तो ऊपर के पार्ट को करेंगे मशीनिंग, बहुत कंट्रोल्ड अमाउंट में करेंगे तभी तो होगा ना. अगर ये अनकंट्रोल्ड हो गया तो पूरा पूरा मशीनिंग कर देगा. अगर ये पूरा मशीनिंग कर दिया तब तो कैविटी बन गया या फिर होल बन गया, वो तो मशीनिंग, वो तो हमारा रिक्वायर्ड नहीं है. दैट इज द रीजन वी व्हाट वी डू द मशीनिंग इन द वेरी कंट्रोल्ड वे एंड बाय द हेल्प ऑफ द केमिकल्स थिंग्स. ओके, and we form these kind of profiles. And the for the plasma arc machining, basically what we are going to see here, we use for the clean and rapid cuts and the profile. So I have explained these things, so for the clean, rapid cuts and the profile, I've explained these things. So these things are the just all in all, in a nutshell, you just remember these things. Very much important shape and cutting capabilities are there. कि अगर मुझे suppose that if I want to go for the micro machining and the micro drilling, I am going to use LBM and the ABM. Fine. That is the way that you should remember these things. Suppose if I want to make a hole drilling, or the standard holes are there, fine. So you are going to use these kind of machining processes for your understanding. Suppose if I want to make a shallow pockets, how I can make a shallow pockets with the help of the aggressive jet machining processes. Next, see. So basically what we have seen from these points, is that ECM has the highest MRR and the USM and the AJM has the lowest MRR. Yes or no? So see here. And we have also seen that the plasma arc machining is very good for the rapid cuts and the profiles, right? चलिए मैं जरा आपको कुछ और चीजों को बता देता हूँ. See here. So we have seen that, just a minute, for the MRR, so MRR is going to be high and MRR is going to be low. Now the processes that is actually making this MRR high, so this is we are getting in case of ECM, and low in case of AJM. These things just should remember. Fine. Now I'm going to tell you that MRR value. Suppose that if you have the machining processes, suppose the machining processes are ECM. What is the ECM? That is electrical chemical discharge machining, है ना. Electrochemical discharge machining में आपका क्या होता है, the machining is, the MRR is of about 10 to the power 4 mm cube per Okay, next process is known as ED. Next is USM, that is the ultrasonic machining. Okay, that is the EBM, electric beam machining is there, again laser beam machining is there. These are the processes, these are the processes. I'm just writing the MRR value. So for the EDM, the MRR value is 5 into 10 to the power of 3 mm cube per minute. For the ultrasonic machining, this is around 180 mm cube per minute. Now you may be wondering, sir, how you are writing these MRR? So these MRR are on based upon the experience. ठीक है, ये ranges में होते हैं. When you will be performing these kind of experiment, you will be finding the MRR in these ranges. Okay, for that reason I am just writing here the experimental values. ठीक है, कि इस तरह से MRR होते हैं. डोंट वरी कि सर ये आ कहाँ से रहा है, नहीं आ रहा है, ये एक्सपेरिमेंटल वर्क से आता है. Now for the EBM, what you are getting, suppose that it is in the range of 10 mm cube per minute, and for the LBM, that is the laser beam machining, that is around 5 mm cube per. Now you can see here, that MRR is actually decreasing in this way, isn't it? MRR is actually decreasing in this way. So just remember that अगर आपसे पूछा जाए कि सर ईसीएम, ईडीएम, यूएसएम, ईबीएम और एलबीएम में सबसे ज्यादा एमआरआर किसका होता है, तो वो तो आप बहुत आसानी से बता देंगे कि ईसीएम का होता है, और लो किसका होता है, एजीएम का होता है. तो आप यहाँ पे बता सकते हैं कि सर एजेएम तो नीचे में रहेगा और ईसीएम तो सबसे ऊपर में रहेगा, तो बीच में क्या रहेगा, तो बीच की ऑर्डर्स को थोड़ा सा याद कर लें. डेफिनेटली दैट इज गोइंग टू बी हेल्पफुल फॉर द कॉम्पिटिटिव एग्जामिनेशन. ठीक है. Now suppose this is a question which has been asked in GATE 2006, that is the arrange the processes in the increasing order of their maximum material removal rate. So I have told you that the maximum material removal rate will be what? See here they're asking to arrange these processes in their removal rate. So we have seen that ECM is the highest. So see, in the option A, ECM is the last. So this may be true. Now EDM is the last. So this cannot be true because they want to arrange everything from the lowest to the highest, isn't it? So I can say that this option A may be true. Now option D cannot be true because it at the last EDM is there. So this is wrong. Again, this is wrong. Now we have to find in the A and the B. Now you can understand, if you could remember basically these chart, so you can understand after ECM, EDM has the most good MRR and the least MRR is having the LBM. So definitely from these things you can understand that after ECM, EDM is the good, then LBM is the first one. So definitely option D would be the correct. Okay, now see here, I can you can remember these things with some kind of tricks also. So what are the tricks that is you can apply here? So see here, you can also think about that CDS, that is the combined defense services examinations are there, right? So you can write like that कि सर यहाँ पे CDS होता है बीच में, और फिर यहाँ पर DBS चला आता है, लास्ट में सारा तो ME होता है, दैट इज द मशीनिंग पार्ट. तो इस तरह से आप कुछ बना करके आप याद कर सकते हैं, सो दैट डेफिनेटली यू विल बी help, these things will be helpful for. Now see, what are the limitations of the NTM processes? So basically we have seen a lot of things about the non-traditional machining. What are the limitations? ये इसके limitation क्या है? Okay, हर चीज की, for each and every coin has the two sides, right? Now this is very much expensive. Yes, that is very much expensive. बहुत expensive होता है. And like suppose that what is happening, see here, ये देखिए 10 to the power 4 mm क्यूब पर मिनट है ना. तो अगर आप कन्वेंशनल से कंपेयर करें तो these are very much less, है ना, बहुत कम होता है MRR. So definitely for those things expensive, it is expensive, MRR is low and skilled labor is required. Next is the limitations of electrical machining method is that work material must be an electrical conductor. You will be understanding, suppose the process is like what? Suppose the process is like ECM, that is the electrochemical machining processes, and the EDM, that is the electrical discharge machining processes. So basically in these processes what is happening, the workpiece should be electrically conductive, should be electrically conductive. Now you will be understanding these things when I would be teaching you the ECM and the EDM process. Don't worry about it. But here, as if now, what we can understand that the problem is that this should be the electrically conductive. Now, if the workpiece is electrically conductive, now this is the mouse. Fine. See here. You can see here. This is the mouse that I am holding in my hand. Now, this is not electrically conductive. Either this is made of a plastic and the fiber things are there. But definitely these things are not electrically conductive. Now, if I want to machine these things, how can I machine these things? So that is the reason means like EDM and ECM is very much selective कि सर अगर मुझे इलेक्ट्रिकली कंडक्टिव वर्कपीस दीजिएगा तभी मैं मशीन कर पाऊंगा. तो ये सब भी कुछ कुछ लिमिटेशंस होते हैं कुछ कुछ प्रोसेसेस में. एंड ऑल्सो हियर द कंजम्पशन ऑफ इलेक्ट्रिकल एनर्जी इज वेरी लार्ज. Okay. And the NTM process which has not been proved commercially economical. What is the commercially economical? Means like suppose if you want to make some of the things for the commercial purposes, for like very large purposes, very large quantity में आप बनाना चाहते हैं और उसको बेचना चाहते हैं. But that thing, if you want to make a profit from that, then these machining processes such as USM, AJM, that is the ultrasonic machining, abrasive jet machining, chemical machining, electron beam machining, plasma arc machining, these things are not very much economical from the commercial point of view. So these are the limitations for the processes. Now let us solve the another example of the that question that has been asked in ESE 2012. Which of the following process has very high material rate efficiency? You have seen that the material rate will be very much high for the electrochemical machine. See here, for the ECM process, MRR is going to be very much high, right? And for the AGM, it is going to be low. So very much important. This point is very much important, my dear friend. Please, please, please remember these things. And definitely when I will be teaching you the AGM and the ECM, your all doubts would be naturally getting cleared. Fine. Next question is there, consider the following reasons for using the non-conventional machining. So these are the reasons that you want to high strength alloys are there. So definitely अगर high strength alloys होगा तो आप क्या नॉन कन्वेंशनल मशीनिंग प्रोसेस करेंगे? हाँ, हम तो करेंगे. यही तो हमने देखा है कि if my workpiece, suppose my workpiece will be much harder, then we are going for the non-conventional machining processes, right? So high strength alloy is there. That is the meaning of high strength alloy. Means what? They alloy means what? पहले तो alloy मिला दिए, अभी अब वो high strength का हो रहा है. That is very much harder in nature. For that reason, definitely we are going to imply the non-conventional machining process. Next thing, for the complex surfaces, yes, want to make a very complicated surfaces, and for that complicated surfaces, for that complex surfaces, I would definitely naturally I'm going to imply the non-conventional machining process. For the high accuracies and the surface finish, yes, this is again true. This is again true. These things I have explained in the very first slide. See here again, once again I'm just giving you the very quick recap of that, right? So we have seen these things. Very high accuracies are there, right? Very high accuracies are there. That suppose the very, like you are going for the LOIs, you are going for a very high strength materials are there, high strength materials are there, then you are naturally going to apply the non-conventional machining. Okay, definitely these are the salient points that you should always keep in your mind. And definitely if you will be keeping these things in your mind, you will be able to solve any questions related to this topic. So which of the followings are correct? So definitely these 3 points are correct. तीनों का तीनों सही है ना? So for the option D is going to be correct, that is the 1, 2 and 3. तीनों पॉइंट्स जो है हमारा नॉन कन्वेंशनल मशीनिंग प्रोसेस के लिए वैलिड होता है, बिकॉज इन द नॉन कन्वेंशनल मशीनिंग प्रोसेस वी use the high strength alloys workpieces, we use the complex structure, we make the complex surfaces, we also perform a very complex surfaces machinings are performed with a very high accuracies and the surface. Let's see the next question. That is the ESC 2009. In this question, it has been asked which one of the following statement is correct in respect of unconventional machining processes. That means the four choices are given to you. In this, you have been asked that which choice is correct. Which choice is correct if you are talking about the unconventional machining. Now, see if it is a since it is a MCQ question, that is the multiple choice question, so in this only one option is going to be correct. So if that is the case, you can very easily say the tool is never in contact with the job, है ना। ये हमारा बहुत ही इंपॉर्टेंट पार्ट है कि सर ये टूल होगा, ये वर्क पीस होगा, टूल एंड वर्क पीस, दिस इज द टूल एंड दिस इज द वर्क पीस, there would be no physical contact, no physical contact, no physical contact, no physical contact, ठीक है, कोई कांटेक्ट नहीं होगा टूल और वर्क पीस का, एंड दैट इज द मोस्ट इंपॉर्टेंट थिंग, दैट इज द करेक्ट इज टूल इज नेवर इन कांटेक्ट द जॉब, ठीक है। So since this is MCQ, then only this option is going to be correct. अगर multiple select होता तो different would be the scenarios. So these things are there, and let me let me wrap up the sessions that whatever I have taught to you for the today's session. Now again I'm telling you the questions that is going to be asked in the gate is based upon that which NTM process is based upon which energies, what are the energies that are involved in machining for the whatever the machining processes are there. So that is the thermal energy method. For the thermal energy method, these are the processes, these are the processes, that is the EDM, LBM, PAM, EBM, IBM, and the sources are different. So basically the mechanism is going to be same, that is the fusion, melting, followed by the vaporization, but the sources are going to be changing. That is due to the electric spark. In the EDM, due to the electric spark machining is happening. Suppose in the PAM, that is the plasma arc machining, the high temperature plasma is going to machine these things. So these things are very much important. Suppose we have seen the chemical energy method, we have also seen the corrosion is responsible for the machining things. So these things, just remember these things, my dear friend, remember these things. These things are very much important, because in the gate and ESC directly the questions are asked from these salient points. Naturally we are definitely we are going to see these EDM process or the ECM process or the AGM process in the great detail, but this is an introductory lecture, and this introductory lecture you should be clear in your mind कि थोड़ा थोड़ा आपको पता होना चाहिए कि किसमें क्या होता है, and after that when you will be studying the dedicated section of that AGM or the EDM, आपको बहुत अच्छी तरह से ये सारा का सारा कॉन्सेप्ट्स क्लियर हो जाएगा। नेक्स्ट थिंग दैट यू शुड रिमेंबर दीज थिंग्स, है ना, ये सोर्सेज और मैकेनिज्म बहुत अच्छे से याद कर लें, ये सोर्सेज और मैकेनिज्म बहुत अच्छे से याद कर लें, क्वेश्चन यहाँ से पूछा जाता है। Next thing, shape and the cutting capability. So what are the shapes that you can make from which of the machining processes? Clear? So these things are there. You should always keep in your mind while answering the questions. And these things I have already told you, salient points. That is the thing that you have seen, that MRR is high for the ECM and the low for the AGM processes. And these are the MRR like in the decreasing order. Just you do not have to remember the values. No, you do not have to remember the values. No, never remember the values. But what is the point to tell you about these values, that based upon these values you can say that ECM is more. How you can remember? This is the CDS, combined defense services examinations, है ना। तो CDS आपका पहले होगा, उसके बाद ही कोई दूसरा मशीनिंग प्रोसेस। Next we have seen these things, limitations we have also seen कि EDM और ECM में electrically conductive materials होना चाहिए as a workpiece. So definitely we have solved these things, and I hope you have understood these entire session, and you have not any kind of doubts. And if you have any kind of doubt, definitely you can reach about me. I will try my level best to clear your doubts. If you have understood each and everything, do like this session as well as share this session in your friend circle and the peers, so that they will be also getting benefited. Also, if you are if you want to subscribe for the plus subscription, you want to go for the subscription for the plus or for the iconic, definitely you can use my code SIRVK. You can use my code SIRVK to get a 10% off and to enroll in my personalized mentorship program. So remember my code SIRVK, SIRVK. So I hope you have enjoyed the session. To see you in the next session. For now, thank you so much. Take care.